Welcome to lecture 14. In this lecture, we want to review the concept of static neighborship in EIGRP. Therefore, after this lecture, I expect you to be able to describe and configure EIGRP's static neighborship. Let's start our today's mission. As you remember that, EIGRP routers start their job by sending hello multicast messages to the other routers to discover their neighbors dynamically. With a static neighborship, instead of sending multicast messages, we define the neighbor router IP address and set it as a static neighbor. Therefore, our router is sending unicast messages to the neighbor router instead of sending multicasts. Therefore, we could say that a static neighborship could help us to reduce multicast traffic. But static neighborship when could be useful? A static neighborship could be useful in some networks such as frame relay. Assume that in this frame relay infrastructure, these two routers want to be EIGRP routers and these two do not want. If you configure EIGRP on this subinterface, since frame relay could not send multicast messages, it creates 4 copies of EIGRP hello message and send it over 4 VPCs that has on this subinterface. And a copy of EIGRP hello message is sent to these 4 routers. For these 2 routers, everything is okay and they need these hello messages. But for these 2, they do not need EIGRP packets. And we impose overhead traffic by sending EIGRP messages on these PVCs. The PVC between this router and this router, and the PVC between this router and this router. In these situations, static neighborship could help us. We define these 2 routers as the static neighbors on this subinterface, and this router sends unicast messages to the defined routers and they use the static neighborship benefits. If you configure static neighborship on an interface, the router will not process EIGRP multicast messages after that on this interface. Therefore, clearly, if you configure static neighborship on a subinterface in this side, you have to configure it on this side too. Otherwise, the neighborship between these 2 routers will lose because you configure static neighborship here and this router still uses multicast messages and multicast messages does not process on this router. Therefore, the neighbor relationship between these 2 routers will lose. So remember that if you configure a static neighborship on this interface, you have to configure a static neighborship on both of these interfaces. Otherwise, the neighborship relation between the routers will lose and they won't be neighbors anymore. For configuring static neighborship, I choose a simple topology. I connect 3 routers to a switch and configure the network of 192.168.10/24 for the interfaces, 1.1 for this, 1.2 for this, and 1.3 for this, and configure EIGRP with the AS number 1, and all of these routers should advertise network 192.168.10. Remember that even with a static neighborship, you have to configure EIGRP with the network command. It is true that we want to define our neighbors, but you have to configure network command and start EIGRP on these interfaces. Now I want to show you these configurations. If I issue show IP interface brief on the router 1, you will see that I set 192.168.1.1 on the interface fast Ethernet 0/0. And if I issue show IP EIGRP neighbors, you see that I have 2 neighbors with the IPs 192.168.10 and 192.168.12 on fast Ethernet 0/0. And I want to show you the Wireshark Capture packets, and you see that the hello messages between the routers are doing with multicast messages from 192.168.1.1, 1.2, and 1.3. All of these routers sending multicast hello messages to each other. Now I want to configure static neighborship on router 1. Therefore, we go to EIGRP router mode with command router EIGRP, the S number is 1, and we issue the command neighbor, and you have to enter the IP address of the neighboring router here. I choose the first one, 192.168.1.2, and you have to enter the interface which this neighbor router is reachable with it. And here for us is fast Ethernet 0/0. And again, you see that the static peer configured, and again we enter the command neighbor 192.168.1.3 and the fast Ethernet 0/0. And now if you see the Wireshark messages, you see that the messages from 192.168.1.1 is unicast messages. You see that 213 and 212. Therefore, now I expect that the EIGRP neighborship between these three routers go down, and we don't have any neighborship between the router 1 and router 2 and 3. If I issue show IP EIGRP neighbors, you see that there is no any neighbor router because I disable multicast process on the interface fast Ethernet 0/0. And if we want to get back everything in a normal state, we have to configure static neighborship on router 2 and router 3 too. So I go to router 2 and say configure terminal router EIGRP1 neighbor 192.168.1.1, and the interface is fast Ethernet 0/0, and do it again on router 3. Router EIGRP1 neighbor 192.168.1.1, and it is reachable from fast Ethernet 0/0. And you see that new adjacency is formed. And now if here I issue the command show IP EIGRP neighbors, and you see that our neighbors come back, and you see that all EIGRP messages are unicast and there is no any multicast messages. Now you see that you could not distinguish between static neighbors and dynamic neighbors. And for example, when you issue show IP EIGRP neighbors, how could we understand these neighbors are static or dynamic? We could extend show IP EIGRP neighbors command with the keyword detail. And you see that here the router shows us this is a static neighbor. This is a static neighbor. Therefore, you could use the detail parameter after show IP EIGRP neighbors to see whether the neighbor is a static neighbor or a dynamic neighbor. Now it's summary time. In this lecture, we learned the concept of EIGRP, static neighborship, and configure it on our routers. I hope this lecture helps you to improve your knowledge, and see you in the next lecture.